desmos calculator allows you to use function notation. So you can call something any function, f of x. It's generally in the middle of the alphabet, f of x, g of x, h of x. But we can, it's given as g of x, so I'm just going to use what was given. And then we type the equation exactly as it appears. So 8x plus 11. Now, if you wanted to, you could scroll through along here and find the point where x is 3, but the easier thing to do is to just evaluate it using function notation. So if we want to say, what's the output when the input is 3, we simply take g of 3, that gives us our answer, 35, and that would be the solution. Okay, so it's as simple as that. So what you can do here is just type in your given equations as a function, and then evaluate your function. So I want you to try these two examples, the one to the right and the one right below what we just did. See if you can solve each of those questions using the calculator. All right, so I'm going to go work my way down. So I'm going to do this one at the right below first. So they just give you a function, and then they ask you to evaluate two expressions, or an expression that contains two of the function notations where you are plugging numbers in. So the first thing, all I need to do is just copy my function, x plus 6 in the numerator over 2. And then I can just type my function notation directly as it appears. F of 11, that's plugging in 11 everywhere there's an x. Okay, and then I'm subtracting f of 8 from that, and it gives me my answer, 1.5. If I want to see that, since all my answer choices are written as a fraction, I just hit this fraction key and it shows the fraction form of that. And so the answer is going to be 3/2. This last question here over to the right. This one gives you, like, you have to read it first. I mean, so when you're looking at it, you see you have a given function, and you're told that x does represent the monthly payment. And so really this is just another way of asking you to evaluate this function when x is equal to 300. So if you understand that that's what the question is asking you, we can take the function as it's given, 60x plus 1100, and we can evaluate it when x is 300. And notice when we plug that 300 into our function notation, it gives us our answer of 19,100. And that would be our solution. Any questions on that, just using function notation directly in the calculator? Right. The next problem is one that we've talked about solving this by setting up a table and then using linear regression. Again, we talked about how to do this by hand already. So for today, I want you just to see, can you remember the steps? Because we've also, I've introduced how to set up a table and use linear regression. So, but remember, when you are using the regression equations, you need one more set of points than the degree of your equation. So a linear equation has a degree of 1, meaning the highest power of x is 1. So that means you need one more than that, or 2 sets of points. They gave you 2 points. So if we go into this plus button, add the item, and choose table, and plug in our 2 points. So -5 and -1 is the first set of coordinates. 2, 1 is the second set of coordinates. Once you enter 2 points, what you can now do is call on the linear regression. And the way to do that is call it y1. Once you type the 1, it'll automatically subscript, and you need the subscript. If you look at your table, you're calling in x sub 1, y sub 1s, so you need to call on those with the subscripted 1. Bless you. Okay, and then instead of an equal sign, you're going to use this tilde button, this little similar to. So if you go into the keyboard, I'm going to show you where it is on the keyboard. Hit the letters, and when it gets to the keyboard letters, it's here on this bottom row. Okay, and now you can type, and I want my answer. You can choose what answer form you want it in. So I want my answer written in the slope-intercept form. So mx1 plus b. When I do that, I get my solutions. Now, all of my answers are in fraction form, so I need to see what m is as a fraction. So just type the letter m, hit the fraction key. You see m is 2/7. There's only one option where that's the case, and so that would be our answer right here. But we can also confirm that b, when we type in b and click the fraction, this fraction button, b is 3/7. That is our y-intercept, which we also see in our answer choice. Okay. Now remember, if you forget the subscript 1, so if I just typed x by itself here, or the y by itself, notice nothing comes up. It's not until you put the subscripts here that it understands you're calling on the linear regression. All right, so this last page is all about kind of using these relationships. So actually, let's see, we'll do these two first. So let's do the two on the left and see if you can practice or review your linear regression. So the first question relies on the understanding that when you take f of x equals y, so whatever f of x is equivalent to your output y, by putting it in this form, you see that this corresponds to an ordered pair, that an input of x gives you an output of y. Okay, so this particular setup requires you to understand that function notation represents the input of 0 gives you an output of 11. So 0, 11 is one of your points. Okay, the next one, f of 1 equals 15, tells you that an input of 1 gives you an output of 15. Okay, now, technically, if you're working through this, the easiest way to answer this question is also to understand that this is your y-intercept, right? The y-intercept is the y value when x equals 0. Well, which graph has a y-intercept of 11? 1, 2, 3, or 4? There's your y-intercept of 11, right? So since that's the only one with a y-intercept of 11, you can solve this without even having to go to the calculator. But if we are going to use a calculator to verify it, or if you didn't catch that, you can come in and add a table. Type in the 2 points. 0 corresponds with an output of 11. An input of 1 corresponds with an output of 15. Call on our linear regression. So y1 is similar to mx1 plus b. You get your answers. Slope is 4. Y-intercept is 11. You see that that has to be answer choice A, the top answer. All right. The second question here, right below, this one is asking you to identify what is the slope of the equation that represents the values in this table. And so the easiest thing to do is just let's plot that in our table, find the equation for it. So if we go to add table, and now I had mentioned this before, but I'm going to reassert. You only need 2 points to create a linear regression for something like this. Now, if you have random, like if you're doing a random sampling, you want to use all of your data points. Okay, but since it's telling us this is a linear equation, a linear relationship, all you need is 2 points. It doesn't matter which 2 you choose. As long as you choose 2 points, you are good. I'm only going to type in 2. Now, if I type all 4, or if you typed all 4, it's still fine. You're still going to get the right answer. Okay? It's just when you are doing that to understand that if it tells you that there's a linear relationship, which it does right here, you only need 2 points. One more than the degree of your equation. A linear equation has a degree of 1. So once I do this, I can call on my regression equation. So y1 is similar to, again, I'm going to go in here, show you in the keyboard. Here's the similar to button. Close the keyboard up. mx1 plus b. Make sure you put your subscripts. And you see that your slope is 19. That's what it was asking you to solve for. Right? It just wants the value of m. And you can see it confirms, right? Your y-intercept is 25. You were expecting that based on the form that they gave you in the problem. Next question, I'm just going to kind of talk you through this. In this particular question, you see that it has this other unknown, right? The a value that represents an unknown constant. So what you could do on a problem like this is you can create or type in your equation. It's going to give you a graph. Okay, so you see your graph right here. And you want to see, you can either scroll in till you get to 5, and you can look at your graph and see, here is the point where, oops, so again you can see here's the point where my output is 5, so I know my answer is going to be 8. That is the solution. Now, you don't even need to go that far. What you can do is you can actually take this given expression, f of a. You don't set f of a equal to anything. You're just going to assign this f of a expression and see the value. And as you move this back and forth, you can see it's getting smaller here, so we need to get it up to 5. And we're just going to slide it until we get to that number that we're looking for, which is the 5 right there. And you can see that that corresponded to an a value of 8, and that would give your answer. Now, instead of using the slider, you could also just check these 4 points, right? You know one of them is your answer. So when a is 22, we get 8.5. That's not it. When a is 8, we get 5. That is it. We'd get our answer right there. Let's confirm. If a is 13, we get 6.25, not it. We're looking for 5. And then lastly, if a is 5, we get 4.25. So it's the only one that actually gives you the f of a value of 5 is when a is equal to 8. The next type of question is one that, again, using the desmos calculator is a huge advantage, and that is solving systems of equations. Because it gives you, it will plot 2 graphs for you, and you can visually see where the intersection is. Okay, now, remember I had mentioned before, anytime you are being asked on the SAT to find an expression that's not just the variable, you can usually find a way to directly get that equation. So here, if I put my 8x on this side and then subtracted a y, 8x minus y is equal to 0. So just rearrange those and add it straight down. I'd get my 14x. The y's cancel, and I get 42. So really the easiest way to solve this is just to do a quick little mental calculation on it. But you can also use Desmos to solve this. Just know that your answer is going to be 14 times whatever we get for our x value. So if I type these 2 equations in, so y equals 8x is one equation, and 6x plus y equals 42 is my other equation. I'm going to zoom out to see where they intersect. And you can just highlight either one of them, and you get your point, 324. So an x coordinate of 3, a y value of 24. You want to find what 14x is. So our x value was 3. So our solution is going to be 14 times 3, which is 42, and confirms our answer. All right, so I want you to see if you can solve these remaining 2 questions here using the intersection of graphs on the Desmos graphing calculator to guide you. So one on the left, if you just, again, this one is set up in such a way that if you just combine straight down the columns of like terms here, the y's are going to cancel out completely, and you get a total sum of x over a total sum of 8 plus 16, or 6, which is 14. So that's, again, the easiest way to solve this would be by hand. But if you are typing in the equations, 1/2 y equals 8 as one equation, and x minus 1/2 y equals 6. Find where these intersect. You can click on either one of them, and when you do, you get 14 and 16. There's your x and your y. Just be careful. It's asking for the x. What you will likely notice on the SAT is that the other answer, so if you are looking for an ordered pair and just trying to find the x or the y, more than likely the other coordinate is going to be one of the distractors. So is 16 a distractor here? Yeah, just be careful of that. And actually it probably confirms that you have the right answer, because you should expect the distractor to be that. And for the last, this last problem here, if we type the equation directly in, or each equation directly in, and we see where they intersect. Remember, you can zoom in. Desmos is going to give you both the x-intercept and any intersection of points. So here, 5, 1 is the x and y coordinate of the intersection. They want the y value here, so we're looking for 1. But if we had not read that carefully and we answered the x coordinate, it would be one of the distractors too. So just be careful on those. If you're just finding either the x or the y, make sure from a multiple choice, make sure you're choosing the correct one. All right, the very last thing that we're going to do is I want to talk through this problem here. Okay, so this is a problem dealing with a system of inequalities. Okay, so this Desmos will graph a system of inequalities as well. So if you just type your two inequalities, here y is greater than 86, you might have to scroll out to see it. So notice it shades everything that's needed to, or that's part of the solution, where y is greater than 86 here. And then when you type your second equation, 78x plus y is less than 4, where there's overlap, that's your overall solution. So the solution is going to exist in this little corner right here. This upper left quadrant is the solution. So what we're going to be looking for on this is which of the following could be values of x. So all I need to do is type in a ordered pair, and I'll call y some unknown. We'll give it just an unknown slider a. It doesn't really matter what that is here. Oops, sorry. The point is, let me go back here. The point is x87. So what we need to do is we need to figure out which of these would possibly be a point where x is our unknown. We'll call it a. Again, give it a slider. And we need to test these 4 points. So here's one. When I look at this point right here, is that point in the overlapping shaded region? No. So I know that 1's not my answer. I can then test, let's test the next one up, -8. Is -8 inside the double shaded region? Yeah, that one is. That means that is my solution. I can stop right here, but I'm going to go ahead and confirm 0. You can see right here falls outside the double shaded region, so that's not it. And then finally I'll confirm that 8's not it either. 8, when I look, here, 8 falls just in this single shaded region, not the double shaded region here. And so that would eliminate that as the answer choice 2. So my only answer that falls in the double shaded region is going to be the -8. And you can either get that with the sliding tool or just entering it specifically and testing each point.